More examples. We need to practice this. This is the most difficult one. 28 minus 13x minus 6x squared. And of course, the larger the numbers, the more difficult it is to find those numbers, blah, blah, blah. Okay. What is it? Trinomial. Is it in descending order?
Yeah.
Very good. How do I rearrange it? Negative 6x squared. Remember, you cannot separate 6 from the sign in front. I cannot separate 13 from the sign in front. I cannot separate 28 from the sign in front. So it's in descending order, greatest common factor? No. Negative leading coefficient? Good. How many terms you're going to give me in parentheses? Very good, and they are? Let's take a moment and check. Negative 1 times 6x squared, check. Negative 1 times 13x, check. Negative 1 times negative 28, check. Correct? Good. Special product? No. 1 is a leading coefficient? No. This is a mess. Why it's a mess? Because the product has to be, I don't even want to multiply it. 6 times negative 28. I'm going to just write it like this. I'll show you in a minute why. Because this is a huge number and I will not know what to do with it. So leave it in the product form for now. And the sum is? Correct. Exactly. Good. Like before, I start by looking at the product. The product has what sign? Negative. Good. If the product is negative, there is only one option. The numbers I'm looking for are? Very good. Now remember, positive and negative, so the distance between them is 13. So one has to be somewhere here and one has to be 13 more than the other, right? Okay. So now this is huge. 6 times 28. I will break it down, as Chris suggested at some point in time, into prime numbers. So I'm looking at 6 times 28. I'll say 6 is 2 times 3. I'll say 28 is 4 times 7, right? Which is 2 times 2 times 7. Do you agree with 6 being 2 times 3? Do you agree with 28 being 2 times 2 is 4, 4 times 7 is 28? Okay. So then I'm looking at this number in prime factors in order. 2 times 2 times 2 times 3 times 7. I have to use all these numbers and come up with two numbers that are 13 apart. I have to use everything. Here's one option. 8 times 21. I didn't mean to start with that first one. Okay, 8 times 21. What's the difference between 8 and 21? Okay, let's say we don't know that. So one option would be 4 times 42. 6 times 4, 7, 42. 4 and 42, no, the difference is not 13. Another one would be 28 and 6. No, the difference is not 13. Another option would be 3 times 8, 24 and 7. No, the difference is not 13. So then I should come up with 8 and 21. I didn't mean to show you the first one. I didn't even think. Okay, so 21 and 8. I have to use everything. 3 times 7 is the 21. 2 times 2 times 2 is the 8. So both conditions are fulfilled. The product is this and the sum is this, guaranteed. Using positive 21 and negative 8.
I have a question.
Yes?
Why did you multiply negative 6 times 28?
Okay. Every time the leading coefficient is not 1, I have to multiply by the free term.
So out of curiosity, even when the leading coefficient is 1, though,
You can still say that you
you can still
multiply.
think of it that way?
Yeah.
Yeah, because that's what I think of, too. All right.
Same thing. Good. So now can anyone dictate the next step? No one can disregard this. Please dictate the next step. You will copy what? Yes, no one can change that. Instead of this, you will give me very good and plus, then you will give me and then you will give me right. We didn't do anything. We just replaced this by these two. We have not changed the problem. We changed the presentation because it's more convenient for us and easier to factor, but we didn't change the problem. Now I'm going to look at the first two terms, completely disregard the last two for a moment, and say I know what to pull out from these two. 3 times 21 is not divisible by 2. 3x. Very good. Now please tell me what is left in parentheses. Very good. What should I have from the other two before I even look? Because who knows what mistake I come up with.
2x.
I always surprise myself. It has to be 2x plus 7, right? So now I look. Remember, I need two things. I need a symbol, and I need something to be pulled out. Even if it's 1, but I need a symbol and something to be pulled out from the other two. You cannot fabricate it. You know it has to be there. How do I know? Because I found those numbers, 21 and 8, or 21 and negative 8. Once I found them, I know it's factorable. There is no discussion there. So, sign. Factor. Awesome. Take a moment and check. Negative 4 times 2x, check. Negative 4 times 7, check. Now, other than negative 1 in front, what is the next common factor to these two terms that has to come out?
2x plus 7.
And something, since these are gone, of course. I have 10 minutes left. I would like to finish Ruby's question and show you the strategy for polynomials. So you can work on all these problems except applications. We cannot do applications yet. I was hoping to do them today, factoring and solving equations by factoring. So we're going to do them on Saturday.
2x squared plus 22x plus 60.
2x squared plus 22x plus 60. Perfect example. Awesome. Okay, what is it?
It's a try.
Descending order?
Yes.
Greatest common factor?
Yeah.
Which one? 2. Very good. Awesome. What is left in parentheses?
Plus 11. 30.
Very good. Okay. Special product. No, definitely not, because 30 is not a perfect square. 5 squared is 25, 6 squared is 36. 30 is not a perfect square. That's another way of looking at it. Okay, perfect. Is 1 the leading coefficient? Much better, right? Much easier. Good. So then I'm looking for two numbers whose product is,
60.
this is completely outside. The leading coefficient is 1. This was taken completely out. So you cannot multiply this from the outside parentheses by this. The leading coefficient is 1. And we are talking about the inside. So the product is
30.
good. And the sum is good. I always start by looking at the product. The product is positive. So then I'm looking for two numbers with the same sign. And since their sum is 11, or positive 11, I'm looking for two numbers having which sign specifically? Positive. So now let's think. Can we find two numbers whose product is 30 and whose sum is 11? 6 and 5. When we add 6 to 5, check, 11. When we multiply 6 by 5, check, 30. Since the leading coefficient is 1, I can go ahead. I do not need the long procedure. I do not need to chase my own tail. It's done. What is it? Only because the leading coefficient is 1. Okay. So let's talk about the strategy for polynomials. One, 2, 3, and 4, same, identical. What is it? Descending order, greatest common factor, negative leading coefficient, all the same. The fifth one, just one, grouping. Factoring by grouping. So if you look at the strategy, there's nothing. That's the easiest of all. Okay, so let's look at a few examples. So the book does this first. Are you kidding me? 6x cubed minus 4x squared plus 15x minus 10. First, I have to ask myself, what is it? How can a student factor this first without understanding what a binomial is, what a trinomial is, and how we even, I don't know. This is the first thing we do in the book. Maybe. Good. So, binomial descending order, yes. Greatest common factor? No. Negative leading coefficient? No. Special product? There is none for polynomials. So, factoring by grouping. Okay. See why I'm doing this with trinomials so I don't have to put more stuff on your shoulders and more methods on your shoulders. Because this is the method we...
Are we done with the question that are we done with that?
Yes.
Question? Okay.
Yes.
So that the
Yes.
final answer was 2x.
2, quantity, x plus 6, quantity, x plus 5. So what would you factor out from the first two? Careful. 2, 2,
X squared.
thank you. What is left in parentheses?
Why is it 2x squared?
Very good. You have,
Because I know everyone was thinking it. then? Why is it?
You have three x's. I have two x's.
Right.
We don't have 3 in common. We have 2 in common.
Okay.
And I have to factor out the greatest.
So then it would be 3x, right?
Yes,
Minus 4, minus 2.
very good. What do I have to have coming out from the other two? Otherwise, I can't continue. You cannot fabricate it. It must be there. Remember what we need. We need a symbol and we need a factor. And we cannot make things up. Plus 5. Let's check. 5 times 3x? Yes. 5 times negative 2? Yes. What is the common factor that comes out now?
3x minus 2.
This is the end of factoring, but these are all sections 6.1 through 6.5. So from the handout that I am looking for right now, here it is, right here. Oh well, I'm lying. I'm looking for the handout with the recommended problems from each section, chapter. I found it. Okay. So let me just tell you what we accomplished so far. All these. So we have to look at 6.6 next week and 6.7 next week. And then we can start reviewing for test 4.